Okay, these are our notes for section 6.2 to 6.5, and these are examples of similarity. Now, two examples where we would use this idea of similarity. We're going to jump right in. We're going to do the first one. The first one, the directions say to identify the similar triangles and find x. Then find the measures of the missing sides, and it tells us the missing sides they want us to find are AC and ED. Now, we've got two triangles here. They're touching each other. They're connected there at B. So the trick is, and this is what catches most people, is writing that similarity statement. Remember, for our similarity statement, we need to go through in the same order, just like a congruent statement. The congruent angles have to match up. So let's start with our similarity statement. Triangle, start with the smaller triangle, ABC, is similar to triangle. Now I started at A. A is an angle that's not marked. So in my other triangle, I need to start with the angle that's not marked. D. D. And then we went to the right angle, which was B. And then to the angle that is marked congruent, which is C and E. So it should be E. So my triangle, my similarity statement is triangle ABC is similar to triangle DBE. And that's how I want you to think through this. Pay attention to the angles because your angles have to match up. Step 2 is to find x. We're going to use a proportion. Now we're going to start with the sides that have numbers. BC is 12 over, and the side that corresponds with BC, I can use my congruent statement, or my similarity statement. BC would be BE, and BE is 15, equals, now I put the small triangle on top, and then the larger triangle on the bottom. So in my second ratio, my second fraction, I need to go back to that small triangle. And in that small triangle, I have x plus 1. The side that corresponds with that, it's AC, would be DE, and DE is x plus 5. Alright, now I solve this. To solve my proportion, I'm going to cross multiply. That gives me 15 times x plus 1 equals 12 times x plus 5. Okay, notice I put the expressions x plus 1 and x plus 5 in parentheses because we have to distribute to both of them. So 15x plus 15 equals 12 times x is 12x, 12 times 5 is 60. Now we solve it from here. Subtract 12x from both sides. 15x minus 12x is 3x plus 15 equals, those canceled, so 60 minus 15. 3x equals 60 minus 15 is 45. Divide both sides by 3. So x is 15 divided by 3 is, 45 divided by 3 is 15. Got a little bit ahead of myself. So there's x. I found the second part. Last thing we need to do is find the missing sides. So we're going to plug back in. We plug in x. So AC, which is one of them we have to find, is x plus 1. So I have 15 plus 1, which is 16. So there's AC. For DE, same idea. DE is x plus 5. Now it's 15 plus 5. So DE is 20. Alright? And those are our two missing sides now. AC is 16 and DE is 20. And we found everything we need to for this problem. We have our similarity statement, we found x, we found the missing sides. Okay? That's a typical example of what you'll be doing on your homework. Example 2, same type of idea. The directions are the same. It says identify the similar triangles and find x, then find the measures of the missing sides, and it tells us our missing sides. We need to find our EG and ED. Now the catch here is that it's a triangle in a triangle. And when we have a triangle in a triangle, we are going to redraw the picture so that we have two triangles that we can see. We're going to start with the small triangle. okay? We have 6 and x plus 5, and then we have to put in our letters, E, H, and G. In our larger triangle, this is where what catches people. In our larger triangle, I apologize for that drawing, we end up with 12 over here, E, F, and D, and most people miss this side here. That's the whole side. Most people will just put 9, but really it's x plus 5 plus 9. We got to add those two things together, so it's x plus 14. Okay? Hopefully that makes sense. It's not just the 9. It's split into two pieces right there at G. So we have to add the two things together to get the whole side of the bigger triangle. From here, we're going to identify our similar triangles. We have triangle. Let's start with the small one. EHG is similar to triangle. We got to go through the same way. Started at E to H down to G. So it'd be E, we go to F, down to D. Alright, there's our similarity statement. Now we have to find x, so we're going to use a proportion. Let's start with the small triangle. Let's start with the numbers we know. We have HG, which is 6, and that corresponds to FD, which is 12, equals x plus 5 over, and this is where most people would make that mistake, it's x plus 14. Some people are going to put 9, so pay attention to that. Make sure you got x plus 14. We're going to cross multiply, so we have 6 times x plus 14 equals 12 times x plus 5. We're going to go on to the next page and rewrite this so we have more room to work. 6 times x plus 14 equals 12 times x plus 5. Alright, we're going to distribute. 6 times x is 6x. 6 times 14 is 84 equals 12 times x is 12x, and 12 times 5 is 60. Let's subtract 6x from both sides. Gives us 84 equals 12x minus 6x is 6x plus 60. Now we'll subtract 60 from both sides. 84 minus 60 is 24 equals 6x. Divide both sides by 6. So x equals 24 divided by 6 is 4. So there would be our variable. Now, the last step is to find the missing sides, and we needed to find EG and ED. I'm going to sketch our triangles again just so that we can see them. I'm going to split them up. Sketch the drawing we made. So EHG, 6, and this was x plus 5, and then EFD, this was 12, and we found this to be x plus 14 because it was 5 split, x plus 5, which was split, and then we had another 9, and we added those together. So we got x plus 14. Now to get EG, we're going to substitute in our x. Well, x plus 5, that's what EG is. X was 4, and we get 9. So EG is 9. To get ED, we had x plus 14. X was 4, so 4 plus 14 is 18. So there's ED. Now, again, I want to recap. For this particular example, triangle in a triangle, we're going to redraw the picture so that we end up with two triangles and we can see what the two triangles are. Only thing you need to remember is that you add to get the long side of the larger triangle. And I'll sketch you a real quick figure so you can see that. This is what we started with. We need to add to get this whole side. Okay? Add the two smaller pieces to get that whole side. Okay, those are your examples on similarity. 2 examples typical of what you'll see in your homework. So if you have any questions, go back and rewatch the video or rewatch the video on similarity. If you still have questions, bring them to class next time.